Okay, so I have had a question about a function y equals 7 times tangent of 0.4 times x and locating the x-intercepts of that particular function. And really, I can answer two questions with what I'm about to discuss. We can find the x-intercepts. We can also find the vertical asymptotes. Those are the two things that we did identify when we were doing this section in our trig unit. But both of them require the same, I guess, pre-knowledge. Both of them require that we recall our parent function, y equals tangent of x, not only what it looks like, but also where its x-intercepts and its vertical asymptotes originally occur. So if you will recall, your parent tangent function looks similar to a repeated cubic function. So this right here is what we refer to as the primary cycle of that tangent function, and then it repeats itself over and over and over again. So you would have another cycle that would look just like it, another vertical asymptote, and so forth and so on. And so it would just keep on repeating itself like that. And tangent repeats itself every pi. So what that means is your first x-intercept is here at 0. Pi units later, right here, at pi, you have another x-intercept. Pi units after that, so right there at 2 pi, you have another x-intercept. So the pattern for the x-intercepts of the original parent function, you could write it as 0, and then you would say plus or minus pi n, because if you start here and go pi units in any direction, if I went the other direction, pi units, I would be hitting another x-intercept right there. And so that's the original pattern for the x-intercepts. The original pattern for the vertical asymptotes, you would pick one to start with. I will tell you that typically the one we start with is this first one right here. And that first vertical asymptote occurs at pi halves. But then because tangent repeats itself every pi units, that means you go pi units in this direction and you'll be at another vertical asymptote. If you go pi units in this direction, you are now at 3 pi halves. If I start here at this primary vertical asymptote and I go pi units in the other direction, I'm now at the next vertical asymptote, which would be at negative pi halves. And so the equation for the pattern of the vertical asymptotes would say pi halves is your initial vertical asymptote, but then once again it repeats itself every pi. So you would say plus or minus pi n. So what the transformations in the given equation are doing, we were given this transformation and this transformation. This would be a vertical stretch that would make your graph 7 times taller. That's going to have absolutely no impact on the location of your x-intercepts and vertical asymptotes. Okay? This is the only thing that will impact the location. It's going to be your horizontal dilation factor. And 0.4 is 2/5. Okay? And it's the b value. What we have been given is we've been given an equation of the format y equals a times tangent of bx. That's what we've been given. And what b does is it is an insider that lies to you. So if it looks like you are taking all of your x values and you are multiplying them by 2/5, which is what b is as a fraction, what you are actually doing is taking them and multiplying them by the reciprocal of that, okay? And so what that means is you would now be multiplying by 5 halves. So to locate your new x-intercepts, which was what this question was asking, you would take the equation for your original x-intercepts and you would now multiply through by the reciprocal of b, which is 5/2. Now what that means is your original x-intercept is still going to stay at 0. But instead of having to go pi units to get to the next x-intercept in either direction, you will now have to go 5 pi half units in any direction to get to your next x-intercept. Okay? If they also asked you, to find the vertical asymptotes, you would have done the same thing. You would have taken the original equation that located all of your vertical asymptotes, and you would have multiplied by the reciprocal of b, which would still be that 5/2. So this original vertical asymptote, which was at pi halves, is now going to be at 5 pi fourths. And then once again, instead of going pi units in any direction to get to the next vertical asymptote, you would have to travel 5 pi half units in any direction to get to your next vertical asymptote. So as far as this particular question goes, they were just asking for the x-intercepts. And so your original x-intercept stayed at 0. Okay? And so you don't even technically have to write that part. It's invisible. And so you could just write it as plus or minus 5 pi halves n. And that is the formula for your x-intercepts for your dilated tangent function. Okay? Thanks, guys.